In section 4, we're going to look at some further applications of linear equations. So our first question is asking us to find a couple different pieces of information, and one way to do this is to create a table. So we're going to create a table to depict the information given in question 1 to help us solve. So question 1 says, Nana found some coins under her sofa pillows. There were equal numbers of nickels and quarters and twice as many half-dollars as quarters. If she found $2.60 in all, how many of each denomination of coin did she find? So there's a lot of information here. This is a good example of when it is helpful to have a table to organize the information. So I'm first going to draw a table. Down the left column of the table, we need to identify what we're working with. So in this one, it says that she found nickels, quarters, and half-dollars. So that's what we're going to use, nickels, quarters, and I'll call it half D for half-dollars. So we can keep everything straight. Now we have some information about each. We have the number referenced that she found of each. We know that each has a monetary value, and then we'll look at the total. As we read down through again, let's fill in our chart. So it says, Nana found some coins under her sofa pillows. There were equal numbers of nickels and quarters. I don't know how many nickels and quarters there were, but it says that there were equal numbers. So if I call nickels X, see in our number column, that means quarters is also X. And then it says, and twice as many half-dollars as quarters. Well, I don't know how many quarters there were, but I know that there were twice as many half-dollars. So twice as many would look like 2X. We know the monetary value of each. We know ultimately at the end it says if she found $2.60 in all. So we know that the total, so when I add up all these other columns, going straight down, the total needs to be $2.60. Well, in order to figure out the $2.60, I need to know how many nickels we have because that would give me the value of the nickels. I need to know how many quarters because that would give me the value of the quarters, and same with half-dollars. We know that a nickel is worth 5 cents, so 0.05 is our value of our nickel. We know that a quarter is worth 25 cents, so 0.25. And we know that a half-dollar is worth 50 cents, so 0.5, or 50 because we're looking at the money for 50 cents. Now we can figure out the total of each different coin. So for example, if I knew how many nickels I had, I would multiply it by 5 cents to figure out how much money I had there in total. So 0.05 times X will give us how much money we have in total from nickels. Same thing with quarters. 0.25 times X will tell us how much money we have for quarters. And then 0.5, or 50 for 50 cents, times 2X will tell us how much we have for half-dollars. Now when I add these together, I need $2.60 as my total. So that's going to look like 0.05x plus 0.25x plus 0.5 times 2x equaling 260. So here we have 0.05x plus 0.25x plus 0.5 times 2 is just 1. So let's add these together. Here I have 1, here I have 0.25, and here I have 0.5. So that gives me 1.30x equals 260. If I divide both sides by 1.30, that's going to leave me with x equaling 2. So what does that mean? Well, we assigned our variable of x to the numbers of nickels and quarters. So that means that she has 2 nickels, 2 quarters, and 2 times 2 would be 4 half-dollars. Let's see if it works. So if we had 2 nickels, that would give us 10 cents. If we had 2 quarters, that would give us 50 cents. And then 2 times 2 is 4. So if we had 4 half dollars, that would give us $2. Adding these together, 10 cents plus 50 cents plus $2 gives me $2.60. So that means it looks like we have 2 nickels, 2 quarters, and 4 half dollars. Let's try again. Question 2. Johnny leaves Memphis to visit his cousin Ann, who lives in the town of Hornsby, Tennessee, 80 miles away. He travels at an average rate of 50 miles per hour. 1/2 hour later, Ann leaves to visit Johnny, traveling at an average rate of 60 miles per hour. How long after Ann leaves will it be before they meet? So this one's tricky. Let's draw a picture. So John is over here, Johnny, and Ann is over here. We know that the distance between them is a total of 80 miles. We know that John is traveling towards Ann at 50 miles per hour. And we know that Ann travels towards John at a rate of 60 miles per hour. So there's a little bit of information that we have and a little bit of information that we need to figure out. Let's see if we can make this into a chart. So we have information about John, and we have information about Ann. We know the rate, we have information about time, and we have information about distance. Do you remember a formula that we can use that relates rate and time and distance? Well, we know that distance equals rate times time. So rate times time equals distance. So let's see what we can figure out here. Let's read the question again. Johnny leaves Memphis to visit his cousin Ann, who lives in the town of Hornsby, Tennessee. None of that is important, but the part that is important is the 80 miles away. Then it says he travels at an average rate of 50 miles per hour. So his rate is 50. 1/2 hour later. Well, do we know how long Johnny was traveling? We don't, but we could call his time X. And if Ann leaves 1/2 hour later, then whatever the total time is, minus 1/2 hour, will give us Ann's time. Ann leaves to visit Johnny, traveling at an average rate of 60 miles per hour. So we know Ann's rate is 60. How long after Ann leaves will it be before they meet? So let's see if we can figure out our pieces. We know we have a total distance. We know that when they meet, wherever they meet, the total distance covered by adding them together is going to be 80. Because if they meet right here, Johnny drove this far, Ann drove this far, the total is 80. If they meet right here, Johnny drove this far, Ann drove this far, the total is 80. So we know that the total distance that they traveled is 80. We can figure out the distance for Johnny and the distance for Ann by multiplying rate times time, because distance equals rate times time. So 50 times x gives us 50x. 60 times x minus 1/2 looks like that. So let's put this all together. So we know that 50x plus 60 times x minus 1/2, let me scoot that over so it's a little bit easier to see. Equals 80. Then we can distribute and we'll be left with 50x plus 60 times x is 60x minus 30 equals 80. Combine our like terms. 50 plus 60 is 110. Add 30 to both sides. Divide both sides by 110. So we found out that x equals 1. So what does that mean? Well, what did we assign x to be originally? We said x originally, right here, was Johnny's time. So Johnny was driving for an hour. Let's see what it says in the question. How long after Anne leaves will it be before they meet? Well, Anne's time is x minus 1/2. So 1 hour minus 1/2 is 1/2. So they will meet 1/2 hour after Anne leaves. Let's try again. Question 3. Sharon commutes to her office by train. When she walks to the train station, it takes her 40 minutes. When she rides her bikes, it takes her 12 minutes. Find her average walking rate. Her average walking rate is 7 miles per hour less than her average biking rate. Find the distance from her house to the train station. So, we have two pieces of information. We have information relative to walking and information relative to biking. We know that distance is rate times time. So we have the rate, we have the time, and we have the distance. Let's see what we can fill in. It says, when she walks to the train station, it takes her 40 minutes. So time is 40 minutes. When she rides her bike, it takes her 12 minutes. Her average walking rate is 7 miles per hour less than her average biking rate. Well, I don't know the biking rate, but I know her walking rate is 7 miles per hour less. So if I call the biking rate x, then x minus 7 would be the walking rate. Now we have to be very careful here. We are told our times in minutes. However, we're told our rates in hours. We need all of our units to match. So this 40 minutes right here, yes, it's 40 minutes, but it's 40 out of 60. So that is really 2/3 of an hour. And right here it's 12, but that's really 12 out of 60. So that is really 1/5 of an hour. So if we want to keep all of our units the same so that we're able to solve, we'll need to look at this in terms of an hour. So then we can figure out our distance. Well, our distance is our 2/3 of an hour times our rate. Distance is rate times time. So we have our 2/3, we have our x minus 7. Here our distance is our rate, which is x, times our time, which is 1/5 of an hour. Now we know a little bit about this information. The train station doesn't move, whether Sharon decides to ride her bike or whether she decides to walk. The train station stays in the same place. So we know that she's traveling the same distance regardless of how she chooses to get there. So we can equate these two formulas. We can say that 2/3 times x minus 7 equals 1/5 x, because the train station is going to be the same amount of distance away. So let's distribute our 2/3, see if we can simplify everything down. If we do that, we're left with 2/3 x minus 14/3 equals 1/5 x. And now we need to clean all this up. Well, if I make this, let me continue over here so you can see, 2x minus 14 all over 3. See how they have a common denominator? So I put the fractions together. That can equal x over 5. And then I can cross multiply. So that gives me 5 times 2x minus 14 equaling 3 times x. Then, lots of distributing in this one. We can distribute right here, and that will give us 10x minus 70 equals 3x. We can move our 10x over by subtracting it. So we'll have negative 70 equals, subtract 10 from both sides, so negative 7x. Divide both sides by our negative 7, so we'll get 10 equaling x. So what we found out is the distance from her house to the train station is 10 miles. Let's look at a geometry example. In this one, you are given a triangle, and you are asked to figure out the measure of each angle of the triangle. Well, in order to do that, there's one key piece of information that we need to know. That key information is the measure of the sum of the angles of a triangle. And the sum of the angles of a triangle measures just to be 180. So that means if we add all of the angles of the triangle, the total will be 180. So let's do that. So we're given our picture here. We have our angles. So we have x plus 61 for our top angle. We have x for this angle. And we have 2x plus 7 for this angle. And we know that if we add all the angles together, it needs to be 180. So let's look at our like terms again. Here's an x variable, here's another one, here's another one. Here's our constant number, and here's another. So let's combine our like terms. So we have x plus 2x. That gives us 4x. We have 61 plus 7. That gives us 68. So now we need to solve it down. If we subtract 68 from both sides, we'll be left with 4x equals 112. If we divide both sides by 4, we'll be left with x equals 28. So now we found that x equals 28. So that means that we can plug 28 back in for each case where we see our x. So if we do that, well, this one right here, x equals 28. So our first angle is just x equals 28. Our next one is x plus 61. So that's going to look like 28 plus 61. And 28 plus 61 gives us 89. And then we have 2x plus 7. So that's going to look like 2 times 28 plus 7. And 2 times 28 plus 7 gives us 63. So now we found the measure of the three angles of our triangle. We have 28, 89, and 63. Let's try one more. Our last question says, find 3 consecutive integers such that the sum of the first and twice the third is 39 more than twice the second. So let's dissect this for a second. It says find 3 consecutive integers. Consecutive means in a row, like 1, 2, 3, or 6, 7, 8, such that the sum, so sum means addition, of the first and twice the third is 39 more than twice the second. So we have 3 consecutive integers. So if we call the first one x, that means the next one would be x plus 1. That means the next one would be x plus 2. Here's our first number. So let's just do an example. Let's say x, pretend it was 5. So the next number would be 6, and the next number would be 7. These are 3 consecutive integers. So the first one would be 5, so that means the next one would be 5 plus 1. So that's how we got the x plus 1. And that means the one after that would be x, our original, plus 2, 5, 6, 7. So that's how we got x plus 2. Now in this case, 5, 6, and 7, that was just to give you an example of how we got the x plus 1 and the x plus 2. So let's get rid of that because it doesn't relate to our problem. Let's read this through again and see if we can figure out each piece. Find 3 consecutive integers. Okay, so we have x, x plus 1, x plus 2, such that the sum of the first and twice the third. Well, here's our first. We need the sum of the first and twice the third. This is our third. Is, so there's our equals, 39 more than twice the second. So we have twice the second, and we need 39 more than. It would be okay if you did 39 plus the 2x plus 1. That's fine. If it is less, it always has to go at the end, so sometimes it's nice to have it always in the same format. So now we can do our distribution here and here, and we'll be left with x plus 2 times x is 2x, 2 times 2 is 4, 2 times x is 2x, 2 times 1 is 2. And now we have a lot of cleaning to do. X plus 2x is our 3x, 2x, and then 2 plus 39 is 41. We have 3 x's on this side and 2 on this side, so there's more on the left. Let's move this over. So we'll subtract our 2x from both sides. So 3x minus 2x just gives us x plus 4. This cancels, and we have 41. Now we can subtract our 4 from both sides. 41 minus 4 gives us 37. Now remember, we called x the first number. So that means that our 3 numbers would be 37, 38, and 39.